So I'm joined now in Mission Control Houston by somebody who's pretty familiar with what this spacewalk is going to entail, NASA astronaut Doug Wheelock. Doug, thanks so much for joining me. And you've done this before. You've done almost this exact same spacewalk back in 2010.
Yeah, absolutely. It's a little bit different failure that we're experiencing this time around, but the spacewalks to remove this old pump module and replace it with a new spare is exactly the same as what we did in 2010. So we had a lot of lessons learned back then, and so we've implemented those changes into our procedures in the way that we prepare our suits and our tools, and so we'll be ready to go on Saturday.
And so obviously a lot of similarities. So it really is identical. Are there any differences?
Well, the difference is now we learned it was sort of difficult to disconnect these ammonia connectors back in 2010. The pressure, we were running pretty high at operational pressures, 360 psi, and so I had a difficult time disconnecting these connectors. And we learned in the latter two spacewalks during that time frame that if we lowered that pressure, it'd certainly help us in disconnecting and reconnecting those ammonia lines. So we learned that, and we've kind of done some simulation, and we're going to drop the pressure so to kind of give these guys a little bit of a head start when they get outside.
So some lessons learned already. So this is a spacewalk that wasn't planned. This is an unplanned spacewalk. So I imagine there's got to be a lot of stuff to do on orbit just to get ready. I mean, what have the crews been doing over the last couple of days to try and prepare?
Yeah, that's right. We refer to it as a contingency spacewalk, and so the skills really though are fundamental, and we practice all of these skills, just rehearse them over and over again in the pool, and the crew has done these particular skills, and so the skills are the same. But space always has surprises for us, especially when we go outside. A lot of this mechanical hardware that's operating outside is bombarded with all kinds of little micrometeor, little tiny flecks, and also the radiation outside and the temperature swings that we have in day and night passes. These mechanical devices don't operate like they do here on Earth or underwater in the pool. And so we try to simulate those malfunctions and prepare the crew to face those should they occur when they get outside.
And we actually have some video from your last spacewalk. Maybe you can walk us through a couple of the procedures. And
sure.
I'm pretty sure there's a good example of
you see
running
here,
into something you don't expect.
The robotic arm is moving into place, and you can see, you'll probably see some what looks like snowflakes in some of these views, and that's ammonia that's kind of leaking out of this system. And you'll see that there are 3 large connectors and 1 small connector that they're going to have to disconnect and then reconnect to the new pump module. And here I had to I have a makeshift hammer to try to break the ice off of this connector, the ammonia formed ice inside that cavity. There you can see a little bit of snow flurries there, and there you can see the ammonia leaking out of the connector as well. We think that we've got a good solution to this now, where we can lower that pressure and give us a little bit of a better chance of success on the first run. Disconnecting these connectors. This pump module is really a big piece of hardware. It weighs about 800 pounds, and although everything is weightless in space, it still has mass, and F still equals ma in space, and so when you're moving this big kind of double-door refrigerator-sized piece of hardware around, the mass distribution in the thing is not symmetric, and so it's got some interesting handling qualities that we also simulate in our virtual reality lab here in Houston. You can see me on the arm there, hoisting that big pump module out of its place there on the truss, and then Tracy and I went out to get the new pump module, and we have 3 spares on board currently, so we're going to use one of those with these coming up EVAs. That'll leave us with 2 spares, but the crew will also go and get a spare off of one of the outside, it's kind of like a porch area where we keep a lot of these spare parts, and they'll return that pump module. Here's a good view of us inserting the new pump module back in 2010 into its slot, and then you bolt it down. It's got 4 bolts that hold it in place, and it's also got these 4 ammonia connectors and also 5 electrical power cables that connect to it to run it from inside. And then You saw that we were coming, that last scene, we were coming back into the airlock, and part of what we have to do, we have to be ready for, is to, if we get ammonia on these suits, we really need, we do what we call is a bake out, and so we try to stay into the sun for a period of time, and we have smart people on the ground that kind of calculate how much ammonia came out, how much could have contacted the suits, and how long we should stay in sunlight to let that sublimate to space, so we don't bring drops of that ammonia inside of the space station.
Yeah, probably would make for a good atmosphere. A bunch of ammonia floating around.
Yeah, it would not be a good day if we brought ammonia inside. So but we do have precautions for that, and and the crew inside is going to be working very hard as well to get these guys back inside when they're done with their spacewalks, and they are an integral part of the cleanup and also the bake out and preparation of the station for when these suits come back inside, so we're ready for any contingency.
And so you're kind of one of the resident experts on this, having done it before. So, and you're going to be pretty closely involved in these upcoming spacewalks as well. What's your role going to be here in Mission Control?
We've had just teams of people working here at Johnson Space Center to get the crew ready and get the vehicle ready and the suits ready as well. And so for all three of these spacewalks on the Capcom console, which is the capsule communicator console here in Mission Control, just sits just to the right of the flight director, who is in charge of the control room at the time. So I'll be sitting on right seat at the Capcom console, which we call ground IV. So I'll be talking to the crew while they're outside. So kind of walking through their timeline. I'll have their timeline in front of me. They don't. They probably will have parts of it memorized and lots of it practiced inside with body control and stuff inside of the station before they go out. And we also have mock-ups of the fluid connectors inside the space station so they can practice moving these bales and operating these connectors. So I'll be sitting and talking to the crew, and hopefully we'll have a smooth day on Saturday as we disconnect these lines from the old pump, and we'll walk them through their timeline.
Did you get a chance to teach them that hammer technique at all?
Yeah, we've had a couple of video conferences, well, several video conferences with the crew, and so I kind of gave them some tips on how to position their body. Part of probably the greatest nuance when you're outside working, especially, is to get things in a comfortable work area, because the suit is kind of bulky and it's pressurized, and so it'll work against you. And when you get in a wrestling match with your suit, the suit's going to win. So during our training, we learn to work with the suit and have the suit work for us. And so we try to get the crews to get their work site in a good work envelope, and then also to position themselves to counteract forces and torque and things like that. So.
Okay. Well, again, NASA astronaut Doug Wheelock, he's done this spacewalk before, and he'll be helping them out as they kick it off on Saturday. Doug, thanks so much for joining me, giving us a look inside. I really appreciate it.
Thank you.